Hello everyone, welcome to the CS Revelation. Today we're going to focus on SQL queries on multiple tables, and that is using SQL joins and subqueries. Now, SQL joins are important to master. As you progress from beginner to an advanced beginner, you'll soon need to combine more than one table, and to do this, you'll need to use one of several SQL join types. So let's dig into this. So let's get started with SQL joins. Now, there are various types of SQL joins, and we're going to focus on the most popular ones. So we have the inner join, the right outer join, the left outer join. We have a full join, right exclusive join, left exclusive join. There's also the full exclusive join, and this is how we visualize a subquery, a query within another query. We'll take a look at that later. So let's get started with a question that's going to at least get us to understand the order of execution of a select statement. So first of all, let's understand how Oracle executes a simple select statement. So the question is asking to consider the following two tables. So we have a table employee and a table department. And we were trying to write an SQL statement to list all the employees. So we want all the employees listed. Now, technically here in our database, we have two tables. We have the table employee and we have the table department, but we're only concerned with the employees. So if we want the employees, that means that we can get that from the employee table. So I listed here the steps in the order of which, Oracle executes all the parts of a select statement. So by default, Oracle will execute the from part first, and then it will get to the where clause where it finds a condition, and lastly, it's the select part where you have the columns or the functions and so on. So now the from part, so basically where do we get our data? From what table are we getting the data? Technically we're getting this from the employee table, so that is easy to come up with. And then step two, do we need to put any restriction on the rows that are returned? It looks like we want everything, so we don't want specific ones, so we don't need a where clause. And what is it that we want? We want all the data, so we're simply going to put a select star. So this becomes step two here because we only have two-step process. So it's a select star from employee, right? So now I have my Oracle Apex account, and I'm going to try to run this select statement to see if I get everything from the employee table. I called it employee underscore T. So I'm going to run this and let's see what I get. So here I get all the data from the employee table, and that is answering the question. Now, the second question here lists all the employees who work for department with number 4. Now remember, when you given a question, you only work with the data that's given or listed in the question. Do not think that you have access to the data, so you don't really see the actual data. You only work with the information that's given in the question. So it's saying list all the employees who work for Department 4. So here we're talking about all employees, that's employee table. And also the information that's also given is employee with number 4. So do we have department numbers in the employee table? Yes, we do. We have that column, so there's no need to include an extra table. So here in the from part, we get all the data from the employee table. That's the first part we want to answer. And then step two is to add a condition if we have a condition. Yes, the condition says that the department has to be equal to 4. So the column department number, so it's department number, it must be equal to 4, right? So here we added our condition, and then lastly, what do we want? Here we want everything from, so it's all the employees. So let's list, star. Let's test if this works in my database management system. So I'm going to run the query and let's see what I get. So I'll hit run. So it's actually employee-t. Okay. All right. So let me run this. This is what I get. So I get all the employees that work for Department 4. So A. Smith, B. Lewis, B. James, B. Jones, they all work for the department that has the number 4. And all this information is coming from the employee T. Okay, so far so good. Now let's get to the next slide and consider this question. It says, consider the following two tables, same two tables we were working with, employee and department. Write an SQL query to list all the employee names and their departments. So two tables are available in my database, and let's see the information that's listed in the question. So here's the question. So write SQL to list all the employee names. So I want the names of the employees. So where do I get that information from? It is from the employee table. There is the column employee name. Also, we want to list them along with their department names. And where do we get department name? That's in departments table. So automatically you see here that I actually do need two tables, and I need data from two separate tables. So now the situation is different. It's not that I find all my data in just one table. I actually need the two tables, the employee table and the department table, so I can answer this question. So let's take a look there are two ways. So we're going to go through the first way, which is called the Equijoin. We're also going to follow the order that we learned from the previous slide, which is answer the from part, then the where clause, then the select part. So we want to get the data from two tables. The two tables are what? So we say employee. And if we are listing more than one table, we should separate them with a comma. So we get in data from employee and also we getting from department. Now, part two, we need a condition. And the condition really that we need here is called the Equi Condition. That is to find the rows from the employee table and department table, the rows from the employee and the rows from department that have a value in common, right? So when you take a look at the database here, what's in common between the two tables is one shared column, that is department number. So department number is a primary key in department table, but it is a foreign key in employee table. So therefore we say that department number in employee is a reference to department number of department table. So because they have some data that is shared across the two columns, let's find the rows in the employee table and the rows in department table that have equal values. So for example, like the first row here, let's take a look at based on, of course, based on this shared column. So based on the shared column, let's see, this row has department number 4 and this row has department 7. So there's no match there. And then you see here the third row in the department table has department number 4. So there is a match between this row and this row. Also, there's a match between this row and so on. So we're saying that we're getting the data from employee and department, and based on the condition that is that we want the department table from the employee. So it's department number from the employee table. We want that to be equal to the department number of department table. Okay, so this is what I want. So department dot. So using the dot operator really to get access to column names from specific tables. So again, here, so this is the second part. That's just the condition that's going to be used to join the two tables, the employee and department. Now, based on this condition, we're only getting the rows that satisfy this condition. And that condition means that we should have a match between the pairs of rows that we're comparing from both tables. So therefore, we only going to get the rows that satisfy this condition, only the rows that have a matching value across the department number. And to say we want everything, we want to list everything. So let's run this query and let's see what we get. So simply Let's get rid of this and get rid of that. So this is department underscore T because that's what I called it in my database. And this is that. Okay, so this has to be the employee underscore T, and this is department underscore T. So here we're saying the department number of employee table must be equal to department number of department table. So let's run this and let's see what we got. Let's say department invalid. Oh, that's because I misspelled it. So it's department. Okay, let's fix it here, and there you go. Okay, should be fine now. All right, so now notice that we got a list of rows, and this list of rows has a piece of information that's coming from the employee table. Notice this, the first three columns are coming from the employee table, and the other three columns are coming from, I mean, two columns are coming from the department table. And only the rows that are matching. So this is the first row that's coming from the department table. It has a department number 4. And this is the row that's coming from the employee table, and it has a department number that is equal to 4. So 4 is equal to 4, therefore we have this listed. Then we have 28 equal to 28, that's why we have this listed. So therefore we're saying that A. James is working for the technology department, L. Jones is working for the database department, P. Lewis is working for technology, B. Jones is working for technology, and so on. Here it says that we only want the names and the department names. So therefore this star here has to be changed to the actual column names. So I'm going to change this to, I want the employee name. So it's dot employee name and comma, I also want the department name. So I don't want all the columns. I just wanted to list them at the beginning just to confirm that we have a match. But now we don't need that. So we actually want department name and employee name. That's all we want. Okay, so now when we run it, so A. Smith works for technology, L. Jones works for database, P. Lewis works for technology, and so on, right? So we only found the rows that have matching values for the department number on both sides. Okay, so this is how we were to answer this using the Equijoin. Now, the second way here is really to use what we call an inner join, and the syntax for that is that you will add, instead of using the condition, the Equijoin condition, we're actually going to use the inner join keyword. So we're going to say, first of all, we're going to follow this order, step 1, step 2, step 3, and step 4. And here step 1 is to answer the from part, and that is for the table names. So we are getting the data from 2 tables, department and employee. Then step 2 is really to transform this into an inner join. So we should list the first table that we're getting the data from here, which is the employee, in the from part. And then in the inner join part, we're listing the second table that we're joining it with. And that second table is the department table. So we're basically saying, get me the data from employee, but join it with department table. So we're saying get the data from employee, inner join department on this condition. And what is the condition? The condition is that it's the same condition that we used earlier, which is that the department number of employee must equal to the department number of the department table, right? So that is the condition that we're using here. Okay, let me fix the misspelled here. Okay, so again, it's very similar to an Equijoin, except that we're using the inner join command here. So we're saying select whatever columns you're interested in from the employee table, inner join department table. So we're saying join the employee table with the department table, but based on this condition. And the condition is that we have to have matching values for a specific column on both sides, of the join here. Okay, so let's try this in our database management system here. So I'm going to type it here. Let's get rid of this, get rid of that, and get rid of this. We're going to turn that to an employee underscore T. And this one too. Okay, so these are the names of my tables in my database management system. There's no need, by the way, to add an underscore T. I mean, that's not a syntax, necessity. It's just that I named my table employee underscore T in my database management system. But you could name your tables whatever you want. So we said, what do we want? We actually want two columns. It is the employee name and the department name, but at first I actually want star, so that way I can list everything and I make sure that we have matching values on both sides. So let's select this and run it. There you go. We got similar results like the Equijoin, like we had earlier. Notice we have a match here, we have a match here, and we have a match here. So the first three columns are coming from the employee table, and the second two columns are coming from the department table. So here we said we want just the two columns, the employee name and the department name, and that's what we got here. Okay, so the inner join here works similarly to the Equijoin. Now, that is just the first taste of the joins, and later on we're going to take a look at the various types of joins. We should know that, the Oracle database performs these joins whenever multiple tables are, involved in a select statement. So when you list more than one table in the from part, the Oracle database or the database management system that you're using is actually going to perform a join. It's going to combine the two tables. And therefore, you have to supply a condition that based on which there will be a combining of the two tables, a joining of the two tables. So most join queries, they contain a where clause. If they do have a where clause, that means you're going to supply a condition, and that type of join is going to be called an equijoin. But if you're using a different type of a join, and you're using an inner join, an outer join, or a left join, or a right join, then you need to use the keyword join and then the on specific condition. But let's get to that in a second. Now, if we don't add the condition, by the way, this is very important to understand. If we don't add the condition based on which that we're joining the two tables, we're going to end up in like a Cartesian product, it's called, which basically going to combine every possible row from the left table with every possible row in the right table, and that's going to create a cross between the two tables. For example, if you have like two tables that we have 10 rows in the left one and 10 rows in the right one, then we're going to end up with 100 combinations. It's just like 10 times 10. Then we're going to have like 100 possible combination of rows. So it's very important that you add the condition based on which you're joining the tables. So these are the various types of joins. So there's inner join, there's left outer join, right outer join, and so on. So we took a look earlier at the inner join, but let's take a closer look at it. So this is the way it's visualized. So we have a table on the left side, and then we have a table on the right side. And the inner join really is going to return what's matching on both sides. So it's really the intersection between the two tables. So you have a table on the left, which in our case, the employee table, and a table on the right, which is in our case is the department table. And when you perform an inner join, you're only returning the records that have matching values on both tables. So therefore, we say this is an intersection between the two tables. So the syntax for that is that you will have a from first table, which is the table that's on the left, and inner join the table on the right. And then the on command to state the condition based on which we are joining the two tables. And we saw the example earlier. But let's take a look at another, so the same example from before actually, which is that If you're trying to do the inner join of employee table and department table, then you're going to list the employee, which is the table on the left in the from part. And then after the inner join, you're going to type the department table, which is the table on the right. And then on the condition that based on which these two tables are going to be joined. And most of the time, it's going to be based on the columns that are shared between the two tables in question. And that is based on the relationship between the two tables. So most of the time, it's really the primary key and its reference, the foreign key in the other table. So here's a closer look at how Oracle really performs the join, the inner join. So we're taking a look at the inner join so far. So the table on the left is the employee, and the table on the right is the department table. So what's going to happen is that we're going to take every single row from the left table and try to find a matching row on the right table. So we start with the first row here. So we say the condition is based on the department number. Do we have a match between department number of the first row and department number of the first row of department table? The answer is no. Therefore, that's not going to be part of the result of the inner join. Then we move to the next row. So do we have a match? No. And then we move to the next row. We have a match because 4 is matching the 4 of department table. So we have a match between these two rows. Therefore, that's going to be listed as the first result of the inner join. And then we move to the rest of the rows. No match, no match. And then we go to the second row of the left table, and then we try to find a match for it in the right table. There's no match there, no match there, but there's a match here. And because there's a match there, we add that combination to the result set, because we're interested in the rows from the left table and the right table that are matching. So 28 matching with 28. And then we continue, of course, trying to find if there is any other matches. There are no more. So if we're done, then we go to the third row of the left table, and then we try to match it with all the rows from the right table. We have one other row that's a match, so it's returned and added to the result set. Then we move to the other rows and notice, so each one of these rows is going to be compared to all the rows from the right table, and the ones that have matching values or satisfy the condition, they will be added to the result set. So in result at the end, this is what we get. This is the outcome of the inner join of employee table and department table. So this is the result set, which we have proved earlier with our select statement here. Okay, so let's practice this idea. So let's consider a totally different database here. So we have a city table and we have a country table. So the city table here has city name, area code, population, country ID, and the country table has the country ID, country name, and country code. What's matching between the two tables here is this country ID, because the relationship is between these two tables based on country ID. So country ID is a primary key in the country table, but it is a foreign key in the city table. So if we consider these two tables, let's list all the pairs of countries and cities that are related. So technically the question is asking, find all the matching rows between the city table and the country table. So matching means the rows that have, matching country IDs. So if I find a row here in the city table with a country ID that is equal to the country ID of the country table rows, then I'm going to list that as part of my result set. So how do we answer this question? So we're going to use an inner join. That is because we're only interested in the matching ones. So this is the syntax. The syntax is that we have a select statement. And in the from part, that is the first part that we should be answering. So here we are joining two tables. So there should be a table on the left and should be a table on the right. And because we only want the pairs of countries and cities, so we want countries to be listed and in the left side, for example, and cities on the right side. You can do it either way, but you know that would work. So I'm going to say we want everything from country. We're listing the data from country, inner join the other table, which is city. So we're joining country with city, but based on this condition. What is the condition? The condition is that we're saying the ones that have matching country IDs. So therefore, I'm going to say country dot country ID is equal to the city, right? Is equal to the city dot country ID. Okay, so if we have a set of row or a pair of row that satisfy this condition, we'll add it to the result set. See, it's easy to solve this type of questions if you follow the order. The order is that you start with the from part, then the inner join part, then the condition. And usually straightforward. If you know the two tables that you're using for this query, then you list one table on the left, one table on the right, and then you add the condition, which is based on the relationship between the two tables. What am I interested in? Maybe I want the country name alongside the city name. So I'm going to say country name, comma, city name. Of course, I should mention the tables where the column's coming from, but I'm going to give you a shortcut here, is that you can actually use aliases. So instead of like typing here like the whole table name, then dot the column name, you could simply rename these tables. So I'm going to use alias. So I'm going to call this CO for country, and I'm going to call this CI for city. So instead of listing really the country table, the whole name of the table, I could simply use the alias as well. So I'm referring to the country table using this alias. So Oracle or your database management system is going to recognize this CI as if like you're saying city table. So I'm going to do the same thing here, CI dot, and this is CO dot. So you must mention where the column come from. From what table does the column come from? And let's run this. So there you go. So we got the country names, for example, Serbia, and then the city name, Belgrade. So for example, let's confirm that. So Serbia is the country with country ID 2, and Belgrade is the city with country ID 2. Very good. And New York is the city with country ID 4. Of course, it should be matched with the country that has ID 4, that is United States of America. Okay, so that's how you would answer this question. And that's another practice for inner join. Again, remember that inner join only returns the rows that have matching values for the condition. So only the rows that satisfy the condition. Okay, so now let's take a look at, so that was the inner join. Now let's take a look at the left join. Now left join means, as the visualization here shows, that we have one table on the left side and one table on the right side. And it means that we're going to return all the rows from the left table. So simply just return all the rows from the left table, in addition to what is matching from the right table. And if we have, let's say, a row from the left table that has no matching row in the right table, then we're just going to list it. However, the part from the right table that we couldn't find, we're just going to put null for it. Okay, so this is the syntax. It's to select the column names from the table that's on the left. Left join. Now it's not inner join, so we're going to say left join the table on the right. So in other words, we're saying give me everything from the left table plus whatever you find as matching on the right table. That is based on this condition, of course, which is a column that is in both tables. So let's take a look at an example here. So we have the table employee and the table department, and we're going to try to do a left join. Now, of course, the order of answering the select statement helps a lot. So we're saying select from, just always do this, like just put your syntax first. So select from, it's going to be, you decide first of all on what type of a join. So you're using a left join. So you're going to say from left join, and of course on condition, right? So the from part will be answered first. So where we get the data from, it's going to be the employee table, right? So we're going that from the employee table. Left join what table that is on the right. That's going to be department table. And on what condition? Let me use alias here. So I'm going to call this E and I'm going to call this one D. So on what condition? So that's based on the relationship here. Department numbers must match. So simply we're going to say E dot department number must, department number must equal to D dot department number. Okay, so that's our condition based on which we are joining these tables. So what is it that we want? We want the employees that work for certain departments, but we're doing left join. So we want all the employees, first of all. We want all the employees. Doesn't matter if they have a department they work for. That's why we're doing a left join, because we want everything from the left table, which is the employee table. And then whatever's matching from the department table, we're also going to list. I'm going to put a star here because I want to see everything first, and then I'm going to change it. So it is on E equals that. So let's start from employee table. So what is the area? Maybe because I didn't select. Okay. So yeah. So we're getting all the data from the employee table. So that the highlighted columns here are coming from the employee table. Notice I got all the employees from there. Doesn't matter if they have a department that they work for or not. Alongside the department number and department name that they work for. And notice that Tim Small has no department that he works for. So therefore, we are listing nulls for the department information. So these ones have departments that they work for. That's why we listed the matching ones. And the ones that don't, we're just going to append a null for that part. So we simply get the result set is right here. So we got all the employees and the department names that they work for. But if they don't have a matching one, we're just going to return a null. That's what the left join really does. It's just going to return everything from the left table plus whatever matches from the right table. Okay, so here I'm going to also make this E dot employee name, right? So we want the employee name, and then we want D dot department name. Okay, so now if I run this, I'm going to get those two columns that I'm interested in. Okay, now let's get to a practice for the inner join. So to practice this, we again going to use the city table and the country table. We're using a left join. The question is asking to consider the two tables below, but we want to list all the countries and their cities. Notice this is what made us decide to use the left join. It says make sure to list all the countries that have no related cities as well, right? So you want the countries that have related cities, but also you want to list the countries that don't have related cities. So in other words, we want everything from the left table, which is the country, alongside the cities that are related. But if there are no related cities, we're going to list the countries regardless and append null for the cities. So I'm using a left join. So I'm simply going to copy this and change it here. And that's going to be a left join instead of right join. So the table that's on the left is the country. I want all the country names. I don't care if they have cities associated with them. Alongside with the cities that are associated if I find some. And if I don't, I will just put null. So let's run this. When I run that, notice for the first 6 rows, I have matching values from both tables, country names and city names. For Spain and Russia have no cities, right? in the city table. So therefore, we put null. All of this data, country names, are coming from the left table, which is the country table. That's why we have all the countries listed here, even if they don't have cities associated with them. Okay, sometimes that's the requirement, and that's what you want. You want to list all the countries plus whatever's matching. If there's no matching, we should still list everything from the left table. If it was inner join, if this was inner join, Russia and Spain will be left out. They're not going to be listed here. So notice I'm going to change this to inner join. We're not going to get Spain and Russia listed. That is because those two countries don't have a matching cities, don't satisfy this condition. So inner join only returns the ones that satisfy the condition. So you see, we don't have those two rows. But if we need everything from the left side, then we just simply run it, and then we get all the rows from the left table. Okay. The next type of join is called the right join. And as it's visualized here also, it's basically similar to left join, except that the table that we're getting everything from is the table that's on the right of the join, and plus whatever's matching from the left table. So if you take a look at the syntax here, really what changes is just the keyword right, and of course also the outcome. So the condition is the same, is based on whatever is shared between the two tables. But now we're doing a right join. That means the table that's listed here, which is considered the right table, we will list everything from that table, plus whatever's matching from the left table. So let's inverse this. Let's see what the question's asking here. We want the city, department table and employee table right join. So let's run the left join and compare it to right join. So the left join gave us everything from the employee table plus whatever's matching from the department. Now if I do right join, that means I want everything from the right table, which is department table, plus the employees that are working for that department. So let's see. Notice now I get all the department names. Doesn't matter if they have employees working for them, because I want everything from the right table, which is the department table, plus whatever is matching from the left table, which is the employees. That means the employees that work for those departments. And you see, like the pensions and the sales and the salary department, they don't have employees, but still we listed them because we want everything from the right table, and we just put null for the employee names. Okay, so that's simply what a right join is. Let's actually take a look at a practice here. Consider these two tables and list all the cities and their countries. Make sure to list cities that have no related countries as well. In other words, I want everything from the cities. I don't care if there is any countries associated with them in the country table. So that's basically turning this into a right join instead of a left join. So I want everything from the right table, that's the city table, and whatever's matching from the country table. Notice what we get. Because we have all the cities that we have in our city table have actually matching country tables. That's why we got all this. So that is the answer to this question. Now, a full join is basically everything from the left table plus everything from the right table. That is, of course, considering the matching rows and the non-matching rows, okay? And of course, we're going to put a null if we have no matching. Now, it's like you're doing a left join and doing a right join and then just combining them together, right? So the results of the left join plus the results of the right join, put them together, right? If I was to think about this, because the inner join is the intersection between the two tables, the table on the left and the table on the right. The full join is basically a union. We're doing a union between the table on the left and the table on the right. So if I was to, for example, take a look at the table department and the table employee, and if I want to do a full join, I'm going to simply do this. So it is going to be full join. Let's see what the outcome is going to look like. So full join is going to give me everything from the employee table. Notice all the employee names, even if Tim Small still doesn't have a department that they work for. And I also have all the department names even though some of the departments don't have employees working for them. So that is basically everything from the left and everything from the right. Match the ones that have matching conditions, but the ones that don't, just put nulls, on whichever side that's missing information. I can also think of this, like I said earlier. Um, I think of an inner joint as an intersect, and I think of a full joint as a union. And in SQL, we actually have we can use an inner and I'm sorry, using intersect and using the union. So let me prove that to you. So I'm going to copy this. So what I'm going to do, I'm going to have one that is going to be, this is a left join and this is a right join, right? So I have one that is doing the left join, this one, and this one is doing the right join. And I'm going to simply say intersect, right? When I do intersect, that means give me the intersection of the result sets of these two queries. And when I run it, I get basically what the inner join is going to give me as a result. And if I do the union, I'm going to get a result set, which is similar to the full join. There you go. So this is the full join. This is how the full join what the full join gave us earlier. Okay, so this was the part about using inner joins, and in the next part, we're going to talk about subqueries. Okay, so SQL subqueries. Now, the best way to look at this idea is to think of this as we have one query nested within another query. And a subquery could be nested within a select statement, an update, a delete, or an insert. And usually, a subquery will be placed in either the where clause, the having clause, or the from clause of any statement. And the order of the execution, if you have, let's say, a query nested within another query, the order of the execution is that the subquery, the innermost query, is going to execute first, and then the outer query, which is the main query, going to execute next. And the syntax is listed here, is that we're going to have a main query, for example, the select statement, and then there will be a subquery, and the subquery is enclosed in parentheses, and there should be an expression operator that's going to link the main query to the subquery. And subqueries are not really limited to returning just one value. They can return a list of values, and that based on that, also you're going to decide on the expression operator. Because if you're using an equality, an equal sign for the operator, the equal operator, then you're basically saying I'm comparing one value to one value. So you're expecting the subquery to return just a single value. But if your subquery is returning multiple values, then you can use something like equals any, or you can use the in operator, means that you're comparing a value to a list of values. Okay, so we're going to take a look at other examples, and we will see that it makes more sense. Now, let's start with a very, very basic question that is asking us to consider this table called project table. And we are trying to find the projects that have budgets greater than the salary systems budget. So now if we were to do this manually, first we really need to know the budget of the salary system. So really need to know the salary systems budget so we can compare it to the rest of the budgets and see which ones have budgets that are greater. Okay, so now there should be a main query and there should be a subquery. The subquery is going to be responsible for getting the salary of the salary systems budget, and the main query is going to be looking for the projects that have budgets greater than the salary system. So here we have two queries, one query within the other query. So the subquery is within the main query. So let's see how we can solve this. So this is the projects table. Let's type the two queries first of all, and then later we will link them. So the first thing is that we want to get the project budget. So hold on. So we want to get the project budget, right? from the budget table. So from the project table, and we want the one that is for the salary system. So we say where project title, because that's what's given really. So where project title is like what? So that's salaries system. Okay. So this query here is basically going to give me the budget of the project that is titled salary system. Let's see if that's going to give me what I'm looking for. So this is from, project table. Okay, so what do we get? So it's this salary that I'm looking for. And now I'm going to write a query that is going to be looking for the projects that have budgets greater than 17,400, right? So I could basically do select project titles from the project table, right? So from project table, and we say where the project budget is greater than, so we want the ones that are strictly greater than. So greater than 17,400. So we're doing this manually, but later on you'll see that it makes sense. So I can run this and it tells me that the pension system and the payroll system, they have budgets greater than this budget. But I don't want to really type this manually. But knowing that this query is going to retrieve the budget for the project that is titled salary system, I could basically substitute this with whatever this query is going to generate. So we're going to basically say in parentheses, I'm going to place this query that I just simply typed. And now we see that we have one query that is nested within the other query. Let me align it right so it makes more sense. So notice that this query here is nested within this main query, right? So this query has to wait until this query generates a value, so it will compare it to it, right? So this will execute first, which is the subquery, and then the main query will execute next based on the generated values of the subquery. So if I highlight the whole thing, I should get the pension system and the payroll system. Those are the project titles for projects that have budgets greater than the budget of salary system. Okay, so basically we are doing two things. First, we're looking up the budget for the project titled salary system. And then we're looking for all the project titles that have a budget greater than that retrieved budget. Okay, so this is the subquery and this is the main query. Now, this is involving just one table, and you can actually use subqueries with multiple tables. So let's trace this one step at a time just to recap. So step one is the subquery that's going to execute. That means we want to know the payroll's budget. So we need to write a query that's going to get me the payroll's budget if that's what I'm looking for. Here we're looking for the salary system. And then the main query is going to be looking for the projects that have budgets greater than that payroll systems budget. So this is the main query, and this is the operator that I'm using to link the query that is the main and the subquery. Now let's practice this idea by looking at the database that is composed of the country table and the city table. So the question is saying find the country name associated with Berlin, right? So technically this is the first question. So we're looking for the country names associated with Berlin, and Berlin is a city, right? So here the country name should come from, so the country name should come from the country table. And the Berlin is a city name, so it comes from the city table. So two tables are involved in this case. So earlier, if I was to solve this using SQL joins, I would have to say that I need to join the two tables, the country table and the city table, and then I'm going to search the joined tables. But because you're using subqueries, we're going to do it a little bit differently now. So first, we need to look up the country's IDs for the city Berlin, right? So this is going to be the subquery. So we're going to say select country ID from city table, right? So we're looking for the country ID from the city table. And but which country ID I'm looking for? I'm looking for the one that has the city name that is associated with the city name Berlin. Okay, so now this query is going to return the country's ID for that city. So that's country ID 1 is associated with Berlin. And now I could basically take this country ID and go to the country table and look up the country name associated with that ID, right? So let's go. So I say, okay, I found out that Berlin is associated with a country with ID 1. Let's go to the country table. Which one of these countries has ID 1? So I see that ID 1 is right here, and the country name is Germany. So basically, I can add my main query here, and I say select the country name from, of course, the country table, and where. So where the country ID is where the country ID is equal to what this query is going to retrieve, right? That is the result of that. So I have to basically put parentheses here, and I say that in parentheses goes this query as my subquery. So now we have a main query that is looking for the country name associated with the ID that is retrieved by the subquery, right? The subquery is looking for the ID of the country for Berlin city, and this main query is looking for the country name associated with that country ID, right? So if I run this, I should get Germany, and that's what we got here. Now let's look at the second question here. It's asking to find a country name in English having cities with area code equals, let's say, 406, 385, or 576, right? So now we are given the area codes, and we're trying to find the country names. So area code is an information coming from what column? It is actually coming from the column area code, which is located in the city table. And the country names are coming from the country table. So I need two pieces of information from two separate tables. So therefore, it's either that I go ahead and join the two tables or I use subqueries. No, notice that the equality is always going to be based on the relationship between the tables. So the where clause here is always going to be comparing based on that. So the subquery is going to look up the country IDs associated with these area codes, right? So I'm going to keep the same format. Okay, so my subquery here is going to be looking up the country's IDs from the city where now it's not looking for Berlin, it's actually looking for area code in one of these, right? So I can actually use my in operator, and then I list all the values here. So I'm going to say 406, comma, 385, comma, 574. So I'm basically saying, get me the country IDs from city where area code is in one of these, belongs to this set of IDs. So I cannot use the equal operator here because I'm expecting more than one country ID. So it should say equals any. You can say equals any, or you can actually say in. Either way is going to retrieve all the country names associated with those cities. Let's run this. And we get Serbia, Croatia, and Poland that are associated with these IDs. So we got three IDs, three country area codes, so definitely coming from three different cities. So 406 is Belgrade, and 385 is Zagreb, and 574 is Warsaw. So, and if we look up the country ID 5, 5, 3, and 2, 5 is associated with Poland, 3 is associated with Croatia, and 2 associated with Serbia. And that's what I got here. I got the 3 countries associated with the cities that have those area codes. You can also use subqueries in insert statements. So for example, if you want to insert into a table, you want to insert, let's say, the results of a select statement into another table. That's going to be the syntax. So you're going to say insert into table name. So that's the syntax for a classic insert statement. You say insert into table name, and then you say select star from the other table. So basically, the select statement is going to retrieve a set of values, and then you're going to use all those values and insert them into another table. And if we were to write SQL code to copy table employee into another table that is called employee2, we're going to say insert into table 2, select star from employee. So basically, whatever this query is going to return, I'm going to insert it into an employee2 table. So here we have an insert statement and the select statement. So what's the subquery here? It's the select star from employee, and the main query is the insert. Also, you could do that with the update. So for example, you can update a table by setting the area codes, for example, to 718 for the countries that have area code equals country code equals USA, right? So you basically go into the country code is coming from the country table, but the area code is in the city table. So this is a composite. That means it's involving multiple tables. So therefore, we need a query, a subquery, to get me the country's IDs that are associated with this area code USA. And I'm going to update my city table and set the area code to 718 for those country codes that were returned by this subquery. Also, you can delete. So for example, you say delete all cities associated with country code, DEU, or POL. Because we're deleting from the city table and the area codes are in the country table, so the country code is in the country table, therefore we're involving 2 different tables. And I'm going to look up the countries' IDs associated with DEU and POL. Once I get those countries' IDs, I will go to the city table and I say delete from the city table where the country ID is one of these countries' IDs retrieved by this subquery. Okay, so the last part here is that we're going to look at these challenge questions, and let's see if we can solve these questions using subqueries. So the database that I'm working with here is, so there's the table department, and table employee, table project, and of course table participation here. So we have a database composed of 4 tables, and the relationships here are marked here by using the ERD diagrams. These are the relationships based on the shared columns. So department table is related to the employee table by having the foreign key department number, and employees related to participation table by having the employee number as a foreign key in participation table. And also project table is also related to participation table by having project code as a foreign key in participation table. So back to the question. So list all employee names participating in the HR systems project. Now think of this question. What is the information that's given? What's given is that we are listing the employee names, and employee names is coming from what table? It's coming from the employee table. So we have no employee names in any other tables. So therefore, we know that the employee table is involved, and we are here. We are saying that the restriction is that these employee names must be participating in the HR system project. HR system project is a project title, and project title is coming from the project table. So therefore, employee table and project table are involved, and because these two tables are related through the participation table, so therefore the participation table is going to be involved as well. So in this, so we're going to have three tables involved, and let's use the subquery method. So first, we're going to look up what links the participation table to the project table. That is the HR system project. So we're going to say select project code. Yes, project code. So we're going to select the project code from the project table. Okay, so which project code are we interested in? We're interested in the one that is for HR system. So we're going to say where project title. So where project title is like HR system. So it's HR system. Okay, so this is going to get me the project code, which is 64. That's what's it going to give me. So let's see if it does give me that. So I get 64. Okay. Now, if I know the project code for the HR system, I can basically go in the participation table and look up all the employee numbers that are associated or participating in that project code. And technically, it's going to be the last three here. So I basically can write another query on top of this, and I can say select employee. So employee numbers, right? Employee number from the participation table. So from the participation table, where, which ones that I want? I want the ones that are associated with this project code, which is the project code for the HR system. So where project, what is it? Project code, where project code is equal to the project code of the HR system. Okay, so let me align it just to see that that's a subquery of that main query. So this is going to get me all the employee numbers that are associated with this project, that are working on this project. So I get these three employees. So these are the three numbers associated with 64, which is the project code for HR system. Now that I made my way here, to make my way all the way to the employee name, I basically say, give me all the employee names from the employee table associated with these employee numbers. So if I know the employee numbers, I can now determine the employee names. So I'm going to say select employee names. So employee name from, so it's from the employee table. So it's from the employee table where employee number, so where employee number is in this list. So you see, like, this gave me three employee numbers. So therefore, I say in this list of employees. And this is going to become the subquery of this main query. Let me align this, and that's going to make it look more clearer. Okay. So you see here that this is a query that is nested within this query. There's also nested within this main query. So now we have three queries involved. So the innermost query, which is this one, which is looking up the project code for HR system, that's going to execute first. And then it's going to pass that information to the next query in the order, which is the project code that's going to be used in this query. So this is going to execute next and find all the employee numbers in participation table that are associated with this project code. And lastly, the main query here is going to execute and is going to look up all the employee names that have employee numbers in this list of employee numbers retrieved by this query. So if I run this, I should get P. Lewis, T. Gilbert, and B. James. So those are the ones that are working on the HR systems project. Okay, so see here, from this question, the information that's given led us to use three queries. So there are two subqueries within a main query. Let's move to the next question here. So it's saying find project managers for projects having employees from the technology departments participating in. So find the project managers. So the last thing that we're going to look for, this tells you that the last thing you're looking for is the project manager. So the project manager comes from the project table. And the second thing is going to be, so we want the ones that are from the technology department. And this is a department name, technology. Because it is coming from the department table, means the department table and the project table are now participating, involved in this query. So therefore, what's in between is going to be involved because there's no direct relationship between department and project. We have to go through the tables that are in the middle of this relationship. So if I want to make my way from the project table to the department table, I have to involve the participation table and the employee table. So you could probably expect 4 queries here. So first, we're gonna look up so we're gonna have to look up the department number for the technology department. So I'm gonna say select department number. So you see, I'm doing this, I'm generating the query, I'm answering the query the way Oracle is going to execute the query in the order it's going to be executed. And we said that the innermost query, which is the subquery, that's the one that's going to be executed first. So we're going to be starting with that one. So we're going to say select the department. So it's department number from the department table. So it's going to be from the department table where the department name is like technology, right? So is like technology. Okay, so now this should give me, here I see 4. So it should retrieve 4 for me. So department number from department like technology. Okay, department name, yes. Let's see. Okay, why no data found? You know what? Let me, like technology. Okay, let's do it again. So that gave me 4. Yes, I misspelled it earlier. So that is department number that is associated with technology department. Okay, now I could basically make my way back here and I say, look up the employee numbers associated with the department that is 4, right? That is with ID, with number 4. So I'm going to say select employee number from the employee table where the department number is equal to this query's value. Okay, so the reason why I find this very easy, like to, look up these tables, is just because looking at the ERD model, you know that you need to create a query to look up something from this table, so you will get to this table. And in order for you to get to this table, you have to use the relationship. I have to link this column to this column. That's why we're looking up the employee numbers associated with this department number 4. So this is going to give me the ones that are working for the technology department. So there are 3 employees working for the technology department. Next, I'm going to look up the project codes associated with the employee numbers, right? These employee numbers. So these are the employee numbers that work for technology department, right? So now I'm going to look up the projects that they are involved in. So I'm going to say select project code from participation. So from participation table, where the employee numbers associated with those project codes are in this list. I'm using in because, like I said, I have a list of results and it's not just one. So this is going to go in this parenthesis. Align this. So this is what we get. Now, this should give me the project codes for the employees that work for the technology department. So it's going to give me the project codes that are associated with the employees working for the technology department. So I get, these are all the project codes that are associated with the employees working for the technology department. Now that I found the project codes, I could basically now find the project manager associated with these projects, right? So all these project codes, I can basically now find the manager's names associated with them. So I'm going to say select the project manager from where. That's going to be, so project manager is from the project table. So select project manager from the project table where, of course, associated with these project codes, where the project code is in this list of projects. Of course, this is going to be, I could basically list these numbers here in this parentheses, but because I want to do this programmatically, I'm going to just basically place these queries because they're going to retrieve those values in this query. So now I'm going to align it. Okay, let's see the big picture now. So notice that this query is going to get me the department numbers for the technology department. This is going to get me the employee numbers working for that department. And this is going to get me the project codes that are associated with these employee numbers. And this is going to get me the project manager that is associated with these project codes. Okay, so now if I run this, let's see. So it's M. Phillips, H. Harton, and K. Lewis that are associated with employees working on projects and are part of the technology department. Yes, it is very lengthy, and that's the complex it gets, to be honest, but I wanted to give you a taste of what's it like to involve multiple subqueries. So the first query that's going to execute is this one, and it's going to generate department number 4. This is going to execute next, is going to generate, let's say 3, I think, employee numbers associated with 4, department number 4. And then this is going to get me the project codes for those employees. And this is going to get me the project manager for those project codes. Last question here is find the department names having an employee participating in project managed by K. Lewis. Okay, so this is different, right? It's the other way around. We're not looking for the project managers. We're given the project manager, but we're looking for the department name. Okay, so the department name is going to be coming from the department table, right? It comes from the department table. And K. Lewis is the information we're given. That is the project manager coming from the project table. So because these two tables are the ones that have to be involved in this query, therefore the ones in the middle or in between will also be involved. So you guessed it, it's also 4 queries. But now we're looking for the other way around. So we're going to start by looking the project codes, the project code associated with K. Lewis. So first we're going to say select project code, and that is the project code from the project table associated, of course, with K. Lewis. So we're project manager. Project manager is like K. Lewis, right? K space Lewis. And this is going to give me that project code. Let's see, what's it going to give me? It gave me 64. That's the project that is associated with K. Lewis. This is K. Lewis right here, and this is the project that is associated with it. Now, you see, what I'm going to do, I have to get to this table. So I'm basically going to look up the employee numbers associated with 64, right? And then I'm taking those employee numbers and then look up the department numbers associated with those employee numbers, and then take that department number and look up its name. Okay, so that's going to be that. Now let's select employee number from participation table where project code is equal to whatever this query has given me earlier, which is supposed to be 64, right? Remember, when you're working with this type of questions, you don't have access to the data. You just work with whatever you're given here as information in the question, and you will be given just the ERD model, but without actual data. So you really don't need the data to find out the actual query. So this is going to give me the employee numbers associated with the project that K. Lewis is managing. And now I'm going to look up the department code. So I'm going to say select department number from the employee table. That's the next table in the list, where employee number is equal to any of these. So I'm going to say in this list. Okay, and I'm going to place these as my subquery of this main query. Okay, so now we align this. Okay, so this is going to get me all the department numbers that are associated with this manager. Okay, what happened here? Okay, I think I typed it in the wrong place. We don't need this. So I need to place that back here. Okay, now we're talking. All right, so let's run this and let's see if we get the employee numbers. Okay, so let me delete all this. Okay, so when I run this, I will get all the department numbers, department number 4, department 28, and department number 9. Those are the ones associated with employees participating in a project managed by K. Lewis. Now I'm gonna, if I know the department numbers, I can basically look up the department names. That's the easiest part here now. So I'm gonna say select department name from the department table, department table where department number is in this list. So it's one of these department numbers, basically. So look up all the names of departments that may have one of these department numbers. Okay, so now let's align this and let's see how it looks like. So we have 4 queries in total. These are the ones. So we have 3 subqueries and a main query. This will execute first to get me the project code that K. Lewis is managing. This is going to get me all the employee numbers that are participating in that project. And this is going to get me the department numbers that have employees participating in that project. And this is going to get me the department name that have a department number from this list. Okay, so when we run this, we will get technology, database, and HR. Those are the department names having employees participating in a project managed by K. Lewis. Okay, so the question may seem very simple and easy, but to be honest, debugging it is a challenge, and you should know really, or you should take a very close look at your ERD model or your database blueprint, how it looks like, and which ones are involved in this question, and how are they related. That's going to determine the number of queries that you're going to need for answering this question. So that was, a taste or flavor of SQL joins and subqueries. I hope you found this very helpful, and I look forward to projects in database. So, stay tuned. Definitely there will be some more of this SQL databases. So more topics and more challenging questions. And I will end the video here, and I'll see you in the next one. Peace.